Hello everyone, friends. Now, we can move on to the PCB part. From here, we call Run PCB New. Yes, our PCB screen has arrived. First, let's make the settings here. From the File section, we click on Page Settings. I am quoting today's date. We write 1.0 for the revision. I write Arduino Nano Shield in the title. You can write whatever you want here. I write the name I gave to my robots in the company section. I write Mustafa Akın here. We said OK. This part is completed. Yes, friends, you can adjust your board settings from here. If you want, you can also access it from the board setup section in the File section. First of all, we design a double-layer PCB board. KiCad supports up to 32 layers. As you can see, the features found in professional PCB programs are also available in KiCad. Our PCB thickness is 1,6. If you want to manufacture this PCB in China or in your own country, you will get a more affordable price if you use this range. Then, we come to our tracks. In this section, you can determine the track thickness. In this section, you determine the via diameters. I set the track thickness to 0,3. I make 0,5 and 1 millimeter and leave it at that. You can duplicate it here if you wish. These values are sufficient for us. In this design, I said OK. Let's center our circuit. Then we need to call our components. That's why we call it netlist from here. Then we need to select the folder we saved from here. Files existing in the previous one have been prepared to be used here. We say open it. Then we call the update PCB. I am closing it from here. As you can see, our components have arrived. We are leaving it somewhere here. Let's move this with M later. I am rotating with R. We quit again. Then I choose our component. We are moving it with M. I rotated it with R. We leave it anywhere on the screen. Then I click on one connector. Let's move it with M. Yes, friends, placement is important for us after this. Because let's say when you place it like this, it won't be like there. Let's say you take these pins. You need to place according to these pins. I am making the grid value 2.54 from here. This is the sensitivity value in the background. As you go down from here, the sensitivity increases. This is the last part. When we take this, let's do a move again. As you can see, it does not come right on top. You can set it like this. We restore it with Ctrl-Z. From here, I start the grid value from 2.54. I came again. We place our component like this. Then, I take a connector from here again. As you can see, it's sitting right on top of it. These pins will actually also fit comfortably when double-mounted. You can view the board in 3D from here. Is there a mistake? Is there not? You can see it before it even goes into production. Such a PCB image was created because we have not determined the frames at the moment. Yes, friends, I am getting out of here. We are choosing our component again. I am moving, then I rotate it with R. We placed it like this. As you can see, we made it similar to the design here. Now we need to draw a frame. We select edge dot cuts on the right. Then we adjust our frame with add graphic lines. I draw randomly like this. When we come to the same point again, our frame is drawn. You can best see this from a 3D visualization tool. Yes, friends, there was such a design. In general, we can make our connections after determining the design. For this, we select root tracks. Then, we determine our track thickness from here. I make 0,5. First of all, I want to draw this circuit on the back copper surface. That's why we choose it from here. This is the front copper. This is the back copper. I start and I finish. Let's say we started from here. As you can see, we cannot make any other connections. The reason for this is that the conditions in the schematic section continue here. This way, we do not make a faulty connection. If we made a mistake in the schematic part, unfortunately, we have made a mistake here too. That's why connections are also important in the schematic part. As you can see, I think KiCad is the best program for makers. Apart from that, it is a very good program to start with for those who want to design boards. Once you understand the logic here, not much changes in other programs. Of course, the features of the programs may change. Because they are licensed programs, they contain more add-ons according to the needs of the market. However, there are also companies that use this program in the market in your country. The reason they use this program is that they do not pay licensing fees. This way, they feel at ease. If you want, you can do business on the market in this program. You will not have any problems in any way. Yes, friends, we have made our connections.